now that we're at part 2 of this lesson, now we're not only going to take the square root or try to simplify our radicals with numbers, we're also going to do the same with our variables. One slight difference for us is for our variables, think about our rules for exponents. So x to the fourth is really x to the second times x to the second. Remember, we add the exponents. So the square root of x to the fourth is x to the second. The same thing multiplied times itself got me x to the fourth. For x to the fifth, it was really x to the fourth times x. We can find the square root of each of those. X to the fourth, the square root of that is going to be x squared. I can't do the square root of just x, so it just stays square root of x. Okay. Same thing here for x to the ninth. Well, this is really x to the eighth times x to the first. I can take the square root of each of them. X to the eighth, the square root is going to be x to the fourth, because x to the fourth times x to the fourth got me x to the eighth times the square root of x. So I'm not always able to pull out all of the variable out of the problem. And then here, x to the second. Well, that means it was x times x. So the square root of x squared is just x. Okay? But here's the one thing that we have to watch for. With variables, we don't know what number it really was. So we don't know, like with our numbers yesterday, we were always taking that principal square root. We were taking the positive square root. For our variables, we're not quite sure what number it is, so there's no way to know if we were going to get the positive or negative version. So anytime we take the square root and we get an odd number for our exponent, so like here, x to the first, we're going to write it as the absolute value of x. So we're going to say we want the positive version. We want to know how far it is away from 0. We're not worried about its sign. For this one, it was x squared, so it just stays x squared, because no matter whether it was a positive or negative, when we square it, it's going to come back to being a positive number. So when we simplify these, if we get x to the first, or x to the third, or x to the fifth as our answer, we're going to write it in absolute value symbols. If we get x squared, or x to the fourth, or x to the sixth, we're just going to leave it the way it is. Okay? But we're basically just going to pull apart these problems similar to what we did yesterday. We're just going to do it for both the numbers and the variables. So here I have square root of 120a squared. So I start with the numbers. 120, okay, think about what would I multiply to get 120. Well, I could do 4 and 30. And then I've got my a squared. Now I find the square root of any of them that are perfect squares. So the square root of 4 is 2. The square root of a squared is a, but since it's just a to the first, I'm going to put in absolute value symbols. And then square root of 30, 30 doesn't have any perfect squares, so it's going to stay square root of 30. When I write it, I'm going to take everything that's outside of the radical up front, so 2 times the absolute value of a, and then times my radical, times the square root of 30. Okay? So on this next part, we're going to have a little bit of it with our variables, and then we're also going to have a little bit of it where maybe it's been pulled into pieces that are not perfect squares. So we're going to look at how do I reassemble those pieces. So like for instance, number 3. Square root of 3 and square root of 6 are both ones that I can't simplify. But if I multiply those back together, I get the square root of 18. Now that's something I can break into pieces involving a perfect square. So this one would simplify to be 3 square roots of 2. Or number 4, square root of 2 and square root of 5. Neither one of those are perfect squares, but I can multiply them and get square root of 10. Square root of 10 can't be simplified either, so it just stays square root of 10. But I've simplified it down to only one radical instead of more than one. Now back to 1 and 2 with our variables. So again, the variable is just going to hang out in its square root, and I'm going to split the number portion. I'm going to break it up into pieces using my square roots, or my perfect squares. The square root of 4 is 2. The square root of x squared is x, but since it just has an exponent of 1, we're going to put it in absolute values. And then the square root of 7 just stays square root of 7. So 68. So what could I multiply together to get 68? This one is going to be the square root of 4 times the square root of 17. And then I have my square root of y to the 4th. So square root of 4 is 2. The square root of y to the 4th is y to the 2nd, because remember it was y squared times y squared, just like 4 was 2 times 2. But since it has an even exponent, we don't need to worry about the positive or negative versions. And then we have the square root of 17. All right, so let's do a couple more together real quick. And then there's some at the bottom that you can try for yourself. Okay. So here, 5 and 10 are not perfect squares, but I can put them back together to get the square root of 50. Then that can be broken into the square root of 25 and the square root of 2, which gives me 5 square roots of 2. Number 6, I get the square root of 9, that is a perfect square, and then the square root of x to the 4th. Square root of 9 is 3. The square root of x to the 4th is x to the 2nd. So for the variables, think of it as when you're finding the square root, you're dividing it by 2. Okay? Because those exponents got added together to get to the 4, so it must have been a 2 and a 2 originally. So here, 300a to the 4th. So I have square root of 100 times the square root of 3, because that gives me 300. And then the square root of a to the 4th. Square root of 100 is 10. Square root of a to the 4th is a to the 2nd. And then my square root of 3 hangs out. All right, take a look at the next one. Again, we got some numbers in the radicals that are not perfect squares. So let's see if we can put the pieces back together. 4 times 3 is 12. 10 times 6 is the square root of 60. So I have 12, and then I have square root of 4 times the square root of 15, which gives me 12 times 2 times the square root of 15, or 24 square root of 15. Okay. I'm going to do one more, number 12, just so you can kind of see how you would tackle this one. 98 is 49 times 2. And then I have x to the 4th, y to the 6th, z to the 2nd. And I'm taking the square root of each of those. The square root of 49 is 7. The square root of x to the 4th is x to the 2nd. The square root of y to the 6th is y to the 3rd. But because it is a odd number, meaning if that y was a negative number, I could end up with a negative when I multiplied it 3 times. And then z to the 1st, and z is also in absolute values. Okay. All right. Now we deal with the fraction part. Okay, and this one does take a little bit more work, so kind of follow along with me. But remember, one of our rules from yesterday is you cannot have a fraction in your denominator. So by the time we're done simplifying these, we can't have a fraction in the or we can't have a radical left in the denominator. So here's what this is going to look like. We're going to split each of them into its own piece and take their square roots. In this case, square root of 9 is 3, square root of 36 is 6, and then we simplify and get 1/2. Or, if it's possible, you can always simplify in the square root, and this would simplify to be 1/4, which is the square root of 1 over the square root of 4, which is still 1/2. So here, square root of 243 and the square root of 144. Well, the square root of 144 is 12. 243 is 81 times 3, which is 9 square roots of 3. And then we can still simplify. 9 and 12 become 3 square root of 3 over 4. So we still simplify those pieces out of our radicals, as long as we don't have a radical in our denominator. So square root of 50 is square root of 25 times the square root of 2. Square root of 169 is a perfect square. So square root of 25 is 5, and then my square root of 2. Square root of 169 is 13. All right, next one, 54 divided by 4. So this is going to be square root of 9 times the square root of 6 over the square root of 4. Square root of 9 is 3. Square root of 4 is 2. I can't do the square root of 6, so it stays square root of 6. Now, the next couple are going to be where we have something left in our denominator. We have a radical left over there. And we're going to show you how to rationalize that denominator. Okay? That's going to be our key for this one, is something called rationalizing the denominator. Basically multiplying by something so we get rid of that radical down there. So square root of 56 over the square root of 45. So this is going to be the square root of 4 times the square root of 14. This is going to be the square root of 9 times the square root of 5. Okay? Now we simplify it. Square root of 4 is 2. I can't do the square root of 14. Square root of 9 is 3, but I can't do the square root of 5. So here's our problem is I can't have a square root, a radical, in my denominator. Okay? That's one of our rules for fractions, is we can't have that radical left in that answer. So what we do is we want to rationalize it, so we want to multiply by that denominator, specifically the square root of 5. So I'm going to multiply times square root of 5, but I'm going to do the same thing to the numerator. Okay? This is really the same thing as 1, square root of 5 over square root of... I can multiply anything times 1 without changing. So here I do 2 times the square root of 70. And down here I have 3, and then I have square root of 5 times square root of 5, which is the square root of 25. Square root of 25 is 5, so I get 2 square roots of 70 over 15. Okay? So I multiply by that radical to both numerator and denominator. Okay? That turns it into a whole number, okay? Because now I can take that square root, and now I no longer have that radical left in my denominator. All right, so let's see this in action. So square root of 9 is 3. I can't do square root of 3, so I leave it alone. To get rid of everything, I'm going to multiply everything times that square root of 3. So I get 3 square root of 3, and on the bottom, 3 times 3 is square root of 9. Well, that's really just 3 square root of 3 over 3, and then my 3's cancel out, so I'm just left with square root of 3 for an answer. Okay. Next one, square root of 100 is 10. I can't do square root of 7, but I need to get rid of that square root in my denominator, so I'm going to multiply everything times the square root of 7. So my numerator becomes 10 square root of 7. The denominator is 7 times 7, or the square root of 49. Square root of 49 is 7, so I get 10 square root of 7 over 7. All right, next one. 75 is 25 times 3 over square root of 5. So that gives me 5 square root of 3 over square root of 5. So I just simplified it. Now I need to rationalize that denominator by multiplying by that radical. So I'm going to multiply everything times square root of 5. That gets me 5 square root of 15 over square root of 25. And I know my work is kind of taken over, so I'm going to move some work over here. So that gives me 5 square root of 15 over 5, because that's the square root of 25. I can simplify the 5s, and I'm just left with the square root of 15. So a lot of steps there, but we just have to follow our path all the way through. So here I get square root of 2. In denominator, I get square root of 4 times the square root of 2. Square root of 4 is 2 times the square root of 2 over square root of 2. Or sorry, that's in my denominator. So here we have two options. One is we can multiply everything times square root of 2 and then simplify. Or, if you notice, I have a square root of 2 in both numerator and denominator. So those will cancel each other out, just like any other common factor, and I'm just left with 1/2. All right, so here I've got square root of 12 over square root of 5. Square root of 12 is the square root of 4 times the square root of 3, which gives me 2 square roots of 3 over the square root of 5. Now I've got to rationalize that denominator, so I'm going to multiply times that square root. So I get 2 square roots of 15 over the square root of 25, because I can multiply those together. And that simplifies to be 2 square roots of 15 over 5. All right, let's do 2 more together here real quick. So let's do number 8. So I get the square root of 16 over the square root of 10. So that's 4 square roots of 10, or 4 over square root of 10. I multiply everything times that denominator to rationalize it. And I get 4 square roots of 10 over the square root of 100, which simplifies to be 4 square roots of 10 over 10. And then those can simplify to be 2 over 5 and my square root of 10. So I simplify those coefficients out front just like I would a regular fraction. All right, so let's take a look at this number 10 and then we'll be finished. So I have 6 square root of 3. 72 is the square root of 36 times the square root of 2. Well, square root of 36 is 6. So I have 6 square root of 3 over 6 square root of 2. My 6's cancel each other out. So I'm left with square root of 3 over square root of 2. I rationalize my denominator by multiplying by the square root of 2. And I get square root of 6 over square root of 4, or square root of 6 over 2. So I'm just using those rules, but then I need to have that extra step of multiplying by that common factor in order to rationalize my denominator and make it something that meets all of my requirements.